Hello, my name is Kiran and welcome to the Tutorial Academy. This course is all about creating an Android app visual appearance and behavior. And the first place to start is with the XML layout file, which determines the initial appearance of your app screen. Nearly every Android app uses an XML layout file to define the appearance of a screen. I'll describe how the XML file layout is loaded at the runtime as the application is startup. And I will do this with a brand new project that I will create from the Android Studio welcome screen. I will start a new project and I will select one of these activity template. The simplest of this is called the empty activity. It creates a single XML layout file with just one little text view component that displays some read-only text. I want to work with something a little bit more complex than that. It's called the basic activity. It has two level layout, that is two different layout file, and it has a single material design element called the floating action button. On this screen, I'll give my app name. It will be called my favorite pet, and I'll set the package name to com.example.android.user-interface. I'll place my new project in the Android Studio project directory, and I have set my language to Kotlin, and that's the language I'll use throughout this course. I'm setting my minimum API level to API 16 or Android 4.4. As of the late 2018, critical elements of the Android SDK, especially the Google Play Service library, are no longer being maintained to support those older versions of Android. And the devices running those older versions have steadily shrinking market share. That's now at least 1%. By using API 16 as your minimum API level, you eliminate a lot of coding and testing. When the project opens, it will have a couple of different files open. The main activity class is a startup class, and again, I'm working in Kotlin, not in Java. When the app starts, the onCreate function is called automatically by the application framework. The setContentView function references the activity main layout file. Now, notice in my layout directory there are two files here, and this is the activity main. The root element is something called the coordinator layout. That's one kind of a view group component that contains the other views. Within the coordinator layout, there is an app bar layout that contains a toolbar. At the bottom, there is a floating action button view component. If I look at this in the design view, I see the button down in the lower right corner. Notice that this includes decoration reference and another layout file called the content main. It's already open up here on this tab, but you can also jump it to by holding down the control on Windows or command on a Mac and clicking that link. Within this content main file, there is a root element called a constraint layout, and then within that, the text view. When I run the app, I see hello world in the middle of the screen and the floating action button at the bottom. If I toss the floating action button, I see the message replaced with the your own action. So that's the basic of how XML files are loaded at the runtime. The activity is brought to the screen either because it's a launcher activity or because it's called by some logic in the app. In the onCreate function, setContentView determines which layout file will be loaded, and in this app the primary layout file reference a nested layout file, and as you customize your screen, this is where you will make your changes. Every XML layout file contains a set of a component that are interpreted as an instruction for placing visual object on the screen. These are XML files, but they are interpreted and executed in the background as a Java code. Most of the XML elements describe instance of a classes. It's important to know which classes they are so you can look up their capabilities in the API documentation. In this XML layout file, notice that some of these declarations have complete qualified class and the package names. That's because these components aren't a part of a core Android SDK. Instead, they are delivered in a separate library called the Material Design Library. When you create a new project, this package might start with an Android.support or it might start with an Android X. depending on how you create the project, but you are referred to the same component. The Android X packages are the newer. In my primary XML layout file, the coordinator layout is the root element. It manages all the visual components in the screen. The app art layout contains the toolbar, and the toolbar is where you see the icon and the menu at the top of the screen. As I have described previously, the floating action button is placed at the bottom of the screen, and that's because of this layout gravity setting of bottom and in. Now within a coordinator layout you use layout gravity, but within a constraint layout you use constraint. This text view component has a constraint to the bottom, top, left and right of the parents, and that's why it's placed directly in the center of the screen. Notice that the text view component is declared without a fully qualified package, and that's because the text view is a part of a core Android SDK rather than an external library. Also notice that in each of these layout file, there are some namespace declaration. The first one is required for an all XML layout file. The Android prefix is then used for attributes that are a part of a core Android SDK. The app name space is only required if you are using the component from the external libraries. The app prefix is used for the attributes that aren't a part of a core Android SDK. And the tool name space is used for the attribute that only affect what you see in the Android Studio but don't affect what happens on the actual device when you run the app. For example, the tool show an attribute says that this layout file should be shown in the design view in the context of activity main. So when I go into design view, I see this floating action button which is actually declared in the outer layout file. In addition to keyword like parent, you can also use certain dimension. For example, let's say I want to text view component to be little bit closer to the top of the screen. I could add a margin bottom setting. I'll start typing margin and then I choose layout button margin. And I'll set this value at 100 dp, and that's 100 device independent pixels. Now, when I look at the text view, I see it's not quite vertically centered. It's a little bit higher, and if I want to see a more dramatically, I can increase the button margin and I'll see the text view closer to the top. Alternatively, I can completely remove the certain constraint. In the design view, I will click on the text view and then I click this icon at the bottom that delete the bottom constraint. And now the text view float to the top of the screen. I'll dive more deeply into the use of a constraint layout container because it's a critical part of how you design the visual appearance of a screen in a modern Android app. As you build your own Android app, you can design your own activity and screen to make them look exactly the way you need them. So this is the end of this episode. So if you like my videos, then hit the like button and subscribe to Tutorial Academy for more videos like this. And don't forget to share with your friends. Until then, have a nice time. Catch you on the next video.